thank you. I would like to thank the organizers, and I would like to thank you for being there at the last conference of the day. So today I'm going to talk about the Yellow Vest movement, about social acceptability, and about carbon taxation with this paper, Geography versus Income, the heterogeneous effect of carbon taxation. This is a joint work with another PhD student at Paris School of Economics. So the point of this model is to create a model to deal with carbon taxation. And the key point will be that we will have income inequality and we will have living area heterogeneity. So we will assess both the aggregate effects of carbon taxation and the distributive effects. So the motivation for the paper is straightforward. This was the plan for carbon taxation in France. The idea was to implement a carbon tax and to reach originally 100 euros per ton of CO2 and after 250 euros. But what happened is this. We had the Yellow Vest movement 6 years ago. And what happened for the carbon taxes was this. The carbon taxes, since the Yellow Vest protest, has been frozen. So each year, we go further and further from the compared to the plan. So usually, when we want to deal with distributional effect of carbon taxes, we rely on static microsimulation. So here, we are going to rather create a dynamic general equilibrium model, and we'll do this with the IRE model, which will generate an endogenous income distribution. We will have non-homogeneous preferences, and very important, we'll have geographical energy links. And we will compare not one carbon tax, but two carbon tax, a carbon tax on firm and a carbon tax on household. And we will see they have very different effects. And finally, we'll talk about the general equilibrium effect of carbon taxes, and we will maybe redistribute the carbon tax revenue through targeted transfer. And we will show that maybe if you give revenue instead of uniformly across household, if we give revenue to the poor or the rural area people, maybe it may increase welfare. So the key fact is the following. When you look at the data, this is the energy share in total consumption. As you see, if you are poor, yes, you consume more energy in your revenue compared to that if you are rich. Okay, but if you live in a rural area, you consume much more energy compared to Parisian household. So in fact, if you want to talk about energy fiscal policy, yes, you need to include poor versus rich, but more importantly, you need to introduce geographical heterogeneity. Second thing, we don't have one carbon tax, we have two carbon taxes. We have a carbon tax on fossil fuel used by households and carbon tax on fossil fuel used by firm. And we need two carbon taxes because, as you see, in the data, usually there are a lot of exemptions for firms so that the effective carbon tax rate on firms is much lower than the effective carbon tax rate on household. So we will have rural and Parisian household, rich and poor, and we will have carbon tax on household, carbon tax on firms. So the first result will be that when you tax households fossil fuel, households direct emission, it will be regressive. But if you tax firms, if you tax energy used by firm, it will be progressive. Second, we will find that if you want to talk about the losers and the winner of carbon tax, geography is more important than income or wealth. And finally, we will see that when you collect carbon tax revenue, if you redistribute towards poor and rural households, you can in fact mitigate welfare losses. Yes?
Are you also taking into account sources side effects, so differences in labor, capital income, and transfer?
Yes, exactly. We will deal with the use side and the source side effects. So we will calibrate the model so that if you live in a rural area, you don't have the same income process compared to a Parisian household. So I'm not going to show you any equation. This is a big heterogeneous agent calibrated model. I'm just going to show you this slide. Starting from the bottom, we will have the model is calibrated on French data. We will have fossil fuel energy that we import from the rest of the world, and we will have electricity produced locally using capital and labor. This is the N because in French it's more nuclear power. This energy, fossil or nuclear, will be used by firms. So firms, they produce using capital, labor, and energy is the CES basket of fossil and nuclear. And households, energy is a non-homothetic good, so it's a necessary good, and household, when they decide on the energy level, they have to choose between fossil and nuclear. And we will match the fact that rural households, they consume more energy, and especially more fossil energy, and same for poor compared to rich.
That's the share in.
Yeah, I'm going to show you. Okay, this is the energy share in total consumption.
Isn't what you care about the total energy consumption rather than the share?
It's
If the rural household is a lot poorer.
we will have the cross calibration because we will assume that we will match the cross calibration between income and living area. So this may not be a problem. So what we want to reproduce in this model is that if you live in a rural area, yes, you consume more energy compared to Parisian households, but you consume much more fossil energy. So we match perfectly energy heterogeneity related to geographical location. We don't match this, and in fact, it's a bit difficult to reproduce because we have a non-linear shape. So we cannot match perfectly the energy share related to income. I'm not going to enter the detail of calibration, but we match vertical heterogeneity relative to income. We match horizontal heterogeneity related to living area. And importantly, we match the cross calibration. We have the cross calibration between where you live and what you earn. Because if you live in Paris, for example, in Paris, there are a lot of rich people and a lot of poor people, while in a rural area, people are more concentrated at the bottom of the distribution. And we try to match this cross distribution. I'm not going to enter the details of the calibration, just these three parameters. In this kind of model, what matters is the elasticity of substitution. Here, we assume a very low elasticity of substitution because we assume this is a short-term model. Because if the elasticity of substitution was very high, we won't have seen the yellow vest movement. And so we assume that we have a 0.2 elasticity of substitution for household between consumption of good and energy, for firm between capital and labor and energy, and for firms and household between fossil and nuclear energy. Of course, we have a robustness check in the paper. So I'm going to show you the results. I'm going to implement in this model a gradual increase, the plan in France, and we will live in a world with permanent increase in carbon taxation. So we will compute the transition between our two steady state and see the cost associated to this green carbon transition. First result, these are the welfare loss. As you see, taxing household is regressive, while taxing firm is progressive. The carbon tax on household is regressive because, of course, energy is a necessary good. If I tax energy, it's going to hurt poor people, while it won't matter for rich people. So yes, carbon tax on household is regressive. But what is less trivial is that carbon tax on firm is in fact progressive. Why? Because if you tax firms, you will decrease activity income. You will decrease capital income, which is bad for the rich. You will decrease labor income, which is bad for the middle of the distribution. But as poor people rely mostly on social transfers, or more compared to the rest of the distribution, they are less affected. So if I tax firms, it's going to be less regressive than if I tax households.
By
Yes.
taxing firms, you mean like something like the ETS?
No, I mean a carbon tax on the fossil fuel used by firm. I'm a firm and I buy oil and I pay a carbon tax.
Okay, because as the ETS is currently designed, like you would imagine that only like the fossil fuels that are directly consumed by households are not covered by a carbon tax currently, since also electricity is indirect, like is taxed in production.
Yes, yes. In fact, the model is calibrated so that the effective price paid by firms includes the EU ETS price. So we will have this in the model.
But so just out of interest, like what would be the number of like what is actually covered by the ETS in terms of like what share of household energy consumption? Because I would imagine that most of it is electricity, or maybe not, but
Yes, we will have in our effective tax rate, as you see, we have the EU ETS price, which is estimated by the French government. So it will be part of the carbon taxation already in place.
You need to make assumption about the cost for it. So how much of the tax impact the price of the firm? What did you do?
Yes, here we have, here we have a perfect pass-through because some studies have shown that we have a perfect pass-through in the data.
So all the firms, everything to the consumer.
Yes.
Okay.
Yes. Yes.
But I find it still a little bit surprising because you capture these general equilibrium effects on household income, right? So I mean, you tax household consumption, that reduces factor in labor income because that reduces demand.
Yes.
So why does that not translate into source side effects for households as well?
No, this includes source side effect, and this source side effect may affect the rich household, but not enough to counteract the fact that energy being a necessary good, it will hurt mostly poor people. So both include a general equilibrium effect on the source side, but in one case, in this case, if I tax household, the use side outweighs the source side. Here, the source side outweighs the use side. Yeah.
Because you have a link on the bottom, and how dependent on is that on the non-electricity and preferences in terms of if you take out, I'm guessing that's what the third button is, right? Because I noticed that you're overfitting the by income share
Yes.
expenditure. So how much of it is that you bar?
Exactly. If you want, you can read the paper because we have the homothetic, we have the same model without types, just with homothetic preferences. And in this case, it is much flatter. So yes, you're right, it is driven by non-homotheticity. So, second very important thing, as I said before, if I want to understand the winners and the losers, in this case, only losers of carbon taxation, I need to take into account geographical location. Because yes, if you are poor, you suffer more from carbon taxes compared to if you are rich, but the gradient is much stronger related to geographical location. And in fact, geographical location in our model explain 77% of welfare losses compared to 12% for income and 16% for wealth. So if you have carbon taxation, we should have geographical location. Yes.
Is that if I change your location conditional on your income? Or is that
yes.
including the fact that there are income differences across?
Yes, it includes the fact that yes, the income process is different.
So this is partly because people in Paris are richer.
Yes.
So it's not, how much is it if you had someone of the same income and you put them
I
in different
don't
parts of the
remember.
country, what would that, because that's kind of unfair to be like, this is income and this is income plus geography.
Exactly,
whereas
exactly.
Geography is more
Yes,
important.
yes. I don't remember exactly if you control, so. And this was if I take the carbon tax revenue and I increase public spending. But of course, I may want to take the carbon revenue and redistribute it to households. This is what I obtained for different transfer scenarios. Here, we have uniform scenario, same thing for everyone, or you give more to rural, or more to poor households, or more to poor and rural households at the same time. And as you see, if you give a uniform transfer, you can increase welfare, which is good, but you will increase welfare of Parisian households and not so much the welfare of rural households. So the best way to improve welfare in this model is to do the green transfer, which is a transfer calibrated contingent on income and contingent on geographical location. But if you do so, as you see, you have a trade-off between climate efficiency and equity, because if I redistribute the revenue to poor households and rural households, they will consume more energy. As you see, this is the social planner preferred choice when we have welfare and when we have emission. As you see, if I care a lot about welfare, I'm gonna choose the poor and rural transfer. But if I care more about emission, I'm gonna choose to keep the carbon tax revenue into public spending or to redistribute the same to every household. So we have a trade-off between climate efficiency and equity. But we can still increase welfare of everyone. And we also have a trade-off between rural households and larger cities households, because if you do uniform transfer, the only losers you will have will be concentrated in rural and small areas, while if you redistribute to poor and rural households, you don't have many losers in poor and rural areas, but you have much more losers into big cities. So you have a trade-off. So to conclude, three things. When I tax households, it's going to be progressive. When I tax firms, it's going to be regressive. So you don't have one carbon taxes, you have two carbon taxes. And maybe we have an interior solution. So the optimal taxation will be a lot of one taxes, a bit of the other, two equal, we don't know. But we have, sure, an interior solution. Second, geography is more important than income. If you want to talk about the losers and the winner of carbon taxation, you need to take into account geographical location. And third, from a policy point of view, if you target poor and rural households, you can mitigate welfare losses, which is good. You can avoid the yellow vest movement, but you will still have a political choice to be made between rural and larger city. So, thank you.
We're gonna head to the pub now, if anyone wants to join.
We will then go from there to Esther's lecture.
Yeah, all right. And we start tomorrow at 9 sharp, so we're only get here for breakfast at 8:35.
I'm not looking about the ticket, so those who are going into the lecture will are reserved to eat. Must be there 10 minutes before, otherwise your tickets will be given to others.
So the lecture starts at 6:45, so if you can be there like at 6:30.
Yeah.
Yeah.